So the next topic that we're going to cover is called arithmetic sequences. Now the first thing to mention with this is it's all about patterns, and it's all about being able to describe a pattern and to be able to describe a pattern using an equation. Okay, so I'm sure that lots of you have seen things where we've got a series of numbers that increment by a certain value. Okay, so if we've got the numbers like this, 0, 2, 4, 6 and 8, hopefully it's pretty obvious to everyone that there's an increment of 2 in between each number. So this is what we call an arithmetic sequence. Okay, there's a pattern between each number in the sequence, and there's a set difference between each number in the sequence. Now what we can actually do is we can use an equation to describe this arithmetic sequence or this pattern of numbers. And the equation that we can use to describe that is written here. So anytime we've got an arithmetic sequence that is a set difference between each number in the sequence, we can use this equation to describe what the sequence is. So again, we've got some terminology here. Now this t to the n, okay, that just means the term number in the sequence. So we can use this equation to work out what any number is in this arithmetic sequence. Okay, so in this case, we've got our starting number of 0, okay, and what we're going to do is we're going to find out, we want to know the pattern between all of these numbers and an equation to describe the change between these numbers. So t to the n is any term number within this sequence. T to the 1 describes the first number in the sequence. So in this case, the first number in the sequence would be 0. So this is the first number in the sequence. T to the n is the term number you want to find. Okay, n, again here, that's the term number that you're trying to find. Okay. Term number is n, 1 is 1, and d describes the difference between the terms in the series. Difference between the terms. So this is the increment that the sequence is going up or down by each time. Okay, so let's look at how we might use this equation. So if we have this sequence of numbers here, we've got 3, 11, 19, 27, 35 and 43. Hopefully most of you can pick up the pattern here, and the pattern between these numbers is that there's a difference of 8 between each number. So this is what we call the common difference within the sequence, difference of 8. So now if we wanted to write an equation to describe the entire sequence here, we've just identified that the common difference is 8. So that's what our d in our equation is going to be. So we're going to put it into an equation like the above and use this to describe our sequence. So we know that d is going to be 8 in the sequence. Now remember, t to the 1 equals the first number in the sequence. So in this case, the first number is a 3. So t to the 1 equals 3. Okay. N just describes the term number that you're trying to find. Okay. So the n's will actually stay in the equation. So the equation that we can use to describe this series then becomes t to the n. So any term in the series is equal to 3, which is the first number in the sequence, plus n take 1 multiplied by d. Now d in this sequence is 8. Okay, so this becomes the equation for this sequence. Okay, so what we can actually do is we can expand and simplify this equation now that we've got a couple of numbers in there. So using our algebra techniques, the way that we'd simplify this would be, firstly, to expand our brackets. Okay, so remember this 8 out the front, this 8 behind here is 8 multiplied by everything inside the brackets. So when we expand those brackets, we're going to have 8 multiplied by n, and 8 multiplied by -1. So the expansion is going to be 8n minus 8. Okay, we can simplify this further. So any term number in the sequence is going to be equal to, so 3 minus 8 is going to be -5. So our 8n is going to stay as it is. There's no other n terms here that we can collect together and simplify down any further. 3 minus 8 is -5. So any term number in this sequence is going to be equal to 8 multiplied by the number that you're trying to find, minus 5. So if, for example, now we say that we wanted to find the 24th value in this series, what we can do is we can substitute term number 24, okay, in this sequence is going to be equal to 8 multiplied by 24, take away 5, okay, and when we do that sum, what we get is 187. Okay, so 187 would be the 24th term in this sequence above, in this arithmetic sequence. So the final thing I wanted to do was work through one question on these types of sequences. So if we have a look at this question here, what it says is consider the sequence above, or below in this case, 87, 83, 79, 75, 71. Okay, so we want to show that the sequence is arithmetic. So we want to show that we're able to use that equation for arithmetic sequences to describe this sequence. And we can only use that, it's only an arithmetic sequence if there is the same difference between each number in the sequence. So we can quickly work that out. So 87 take 83 is equal to 4, okay? So we're taking away 4 each time, okay? Taking away 4. The difference between 83 and 79 is also, you're taking away 4, okay? And we can see that the pattern continues along. So we're actually taking away numbers this time. So it's important that when we put these numbers into our arithmetic sequence, that our D is actually going to be equal to -4 because the number is decreasing each time. So because there is a consistent pattern in between each number, we've shown that this is an arithmetic sequence, okay? So the T1, or the starting number, equals 87, and we are taking away 4 each time. So T1 equals 87, and sequence shows a decrease of 4 each time. Okay, so the next part of the question says, find the formula for its general form. Okay, so we've already identified that T1 is equal to 87, D is equal to -4. So the formula for its general form can be described like this. So any term number in this sequence is going to be equal to T1, which is 87, plus n, take 1, multiplied by -4. Okay, so again we can simplify this down. That becomes 87. If we bring the -4 round to the other side of the brackets, we've got -4 multiplied by n. N take 1, that is. Okay, I'll just shift that up. We can simplify that further by expanding our brackets now. 87 minus 4n. -4 times -1 is plus 4. Okay, so 87 plus 4 is 91. Can be used to describe any term number in that sequence. Okay, so the next part of that question, so part C, asks us to now find the 40th term. So to find the 40th term, we just simply substitute this into the equation that we've come up with to describe this sequence. Okay, so we're finding term number 40 is going to be equal to 91, take 4 times 40, okay, which equals 91. Now 4 times 40 is 160. Okay, so we've got 91, take away 160, which is equal to negative 69. So that would be the 40th number in this sequence. Okay, so the last part of this question, part D, asks us which term of the sequence is negative 297. Which term of the sequence is equal to negative 297. And what we're actually doing in this case is we're working backwards, okay? So we know now that the term is negative 297, okay? We know that's going to be equal to 91. Take away 4 times n. Okay, so again, this is just an algebraic rearrangement to figure out what n is equal to. So first I'm going to shift the 91. So negative 297, take away another 91 is going to be equal to minus 4n. So if we shift that up again, what we end up with is negative 297, take 91, divided by negative 4 is going to be equal to n, which is our term number. So what this equals is n is equal to 97. Okay, so it's the 97th term, which will be the number negative 297 in this sequence.